The Innovators Network.
Welcome to the Killer Innovation Show, the longest continuously produced podcast in history. Each week, Phil McKinney brings you the insights and strategies to amplify your creativity and innovation skills. Here's your host, Phil McKinney.
Welcome to this week's episode of Killer Innovations. We are now really getting traction into season 18. We've completed 17 years of the show, and we are now in our 18th year. We're starting the beginning of this series of shows with a lot of guest interviews. This is one, we got some feedback from you wanting to hear about other people's innovation stories, but also talking to guests who have maybe early stage ideas, early stage work that, never know, might spark you to innovate in an area. So, and that is what today's interview is about. Today's guest is Rob Tiffany. Rob is longtime executive at Microsoft. He's been in the technology world. He was CTO at Hitachi, then was at Ericsson. Now he's an independent analyst. He's a well-known digital strategist. Actually used to be in the U.S. Navy as a submariner. He's done a number of books and does a lot of public speaking. So I reached out to Rob, asked him to come on to the show. He's working in a new area, and you'll hear him describe it in the interview as being in the bottom of the first inning of something brand new. Now, we do get a little geeky just because of our backgrounds, etc. Apologize for that. So if you're not into the tech end of this, stick with it. I think there's some good things that are in it. And at the end, Rob also points to some other people you may want to be tracking, you may want to be following to stay up in these new areas. The topic of conversation today is around what we refer to as digital twins. Digital twins meaning literally a digital version of something. And then being able to use that digital twin to predict, to be able to correct, to be able to improve whatever it is. Is it a physical thing, like a vehicle or your house or a building or something else? So that's today's topic is around digital twins and how you can use that. Now, digital twins have not really been applied to innovation. Could you create a digital twin and then actually use it as part of your innovation process to create new products, new services, new capabilities? So you're going to want to listen closely. Again, we do get a little technical in a couple of short segments in here just because of our background, and we kind of started geeking out, but stick with it. It's a great topic, something to think about around tool sets and understanding and dealing with the pace of innovation and the complexity of innovation. So with that, before we jump into this week's segment, want to ask that favor. Follow, like, and share. Follow us on social media. Like this episode, helps us get publicized to potentially new listeners for the show. Wherever you get your podcast, you can like this episode. And then also share it. If there's people within your organization or people you just happen to know in your circle of influence, let them know about this episode. Let them know about Rob. Help get the word out. We'd greatly appreciate it. So without further ado, let's jump into this week's episode, the interview with Rob Tiffany.
This episode is sponsored by Zoom. With Zoom, you can streamline your communication, collaboration, and creativity all in one place. Zoom is the market-leading platform that provides video meetings, voice, webinars, and chat across desktops, phones, tablets, and conference room systems. To learn more about Zoom and sign up for your free account, visit killerinnovations.com/Zoom.
So, Rob, what have you been up to? You were at Ericsson. You left at near the first of the year. I know you're doing some analyst work, whatever. What is it you're doing now? How do you describe it?
Yes. So certainly juggling a lot of stuff. Doing some analyst stuff. When you've done everything, like you and I have been around this rodeo several times, and you've seen where all the bodies are buried. People are like, hey, why don't you tell us what you think about IoT or digital twins or 5G or stuff like that? And so yes, people actually somehow pay me money to write reports like I'm an industry analyst. And so doing some of that, doing stuff around, some around the wireless communications and some of the narrowband use cases, a lot of stuff around IoT, a lot of stuff around digital twins. And then I'm advising a bunch of startups and helping those poor folks out. It's tough being a founder, right? And getting going as a startup. And so doing a lot of that. And then the other thing is I still write code after all these years. And so on the side, I've had this foundation called the Moab Foundation, like that picture back there, like Moab, Utah, right? And at some point in the past, I realized, hey, we could use this IoT and digital twin stuff for things beyond just business and commercial and industrial stuff. We could use it for society, and so sustainability, or I don't know if you're familiar with those 17 sustainable development goals from the United Nations. Anyway, I've built kind of a miniature Lumada, Azure IoT, whatever you want to think of it, IoT platform, digital twin thing that runs like on a little Intel NUC thingy to give away, to open source and to give away turns out you can do a lot of good with some of that technology, whether it's agriculture, poverty, hunger, water issues, climate, things like that. So,
well, let's back up a little bit because you've used the term twice, and I want to make sure the listeners understand. What do you mean by digital twin? Describe the broad definition of digital twins.
Yeah. When you think about it in its earliest stage, like it was about describing an asset, really. It's just a digital representation of a physical object. It's expanded over time. People are trying to do digital twins to model processes and other things. Digital twins got their start kind of back with NASA, way back when. I oftentimes, when I describe the history of digital twins, I'm just like, do you remember that movie Apollo 13? and so, to kind of be silly, it's like, you got Tom Hanks up there and everything's going wrong in the capsule, in the LIM, right? The spaceship trying to get home. And it's kind of silly because you go, so basically you have Forrest Gump up there, but luckily Lieutenant Dan was down in Houston at a physical mock-up of the spaceship, and they're trying to save everybody and get them back to Earth. Well, those were two physical twins because that's all we knew how to do back then, right? To troubleshoot stuff. But because of that kind of gave rise to the idea. It was like, you know what? With the rise of computing capability that was coming out of the 60s and into the 70s, it's like, how can we build high fidelity models of these spacecraft, right? And so they kind of went down their path for a while. But as far as the rest of the world knowing anything about it, I'd say it didn't really get kicked off. There was a professor, there's Dr. Michael Greaves. He started talking about a double ganger, but he meant a digital twin. And that kind of got things going maybe in the early 2000s, where using it in manufacturing. And so you saw the rise of this industrial IoT stuff start to happen. And so, like GE, when they had their GE Predix digital stuff, and they were pushing digital twins big time. And so, they popularized the idea of, hey, I'm going to have this GE aircraft engine that's fully instrumented, and there's a digital twin of the aircraft engine. And so there's a lot of value. And because of that, because of IoT and digital twins, you could have a new business model where we could do as a service, like an aircraft engine as a service. Typically, just because, so I'm right by Redmond, Washington, since I spent most of my career at Microsoft. But north and south of us and all around Seattle, you've got all these Boeing manufacturing plants, and typically you buy the plane, but you buy the engine separately. But because of the digital twin and industrial IoT technology that GE was doing way back when, they said, wow, I think we can do just kind of like how Salesforce.com popularized SaaS, right? We could do hardware as a service. It's fully instrumented with all the sensors, and we have a digital representation, and we can predict problems right before they happen.
Mm-hmm.
And so we have the confidence that we could pay as you go kind of as a service, which, a lot of people are strapped for cash. And so maybe it makes it easier to do the sale, right?
Yeah, and it's also dealing with the fact that look, when you and I were early starting in our careers, right, there was a certain pace of innovation. Well, the pace of innovation is accelerating at an unbelievable pace, and with that comes complexity. A jet engine 25 years ago is a lot different than a jet engine today, and it's going to be a lot different than a jet engine 25 years from now.
You're right.
And it's hard to understand all the interdependencies and all the little things that need to go right and could go wrong.
Yeah.
And
absolutely.
And, I think one of the dings that the digital twin space has taken is fidelity.
Yeah.
What is the fidelity of the digital twin? Because you just can't assume that someone claims it's a digital twin, that it has all that fidelity,
right?
That's needed. So what?
No, that's a good point. I speak at a lot of digital twin conferences, and things like that. That was because you always had this IoT, and then people realized maybe there wasn't any money in consumer IoT for connected coffee makers or whatever. And then they go, oh, the money's in industrial stuff. Okay, let's instrument industrial robots on an assembly line or whatever. And then the what, after a while, how lots of things in technology, when you first start with it, it seems like magic and it's amazing. I remember feeling that way about IoT. And then over time you go, oh, this is actually just plumbing. There's nothing special about this. The digital twins and applying the analytics and all that stuff, the digital twins to drive insights, right? That drive value is the what, the reason for doing it. And so being able to get to that point and do that. But you're right. So I speak at these conferences, and it's like a cliche. If I asked 100 different people what a digital twin was, I'd get 100 different answers. Right. I think that's where we are today, maturity wise. There's a lot of low fidelity stuff. I think a lot of if you look at a lot of IoT platforms from either the hyperscalers or whoever, there's so many players, right? I blame McKinsey for all of this. You said it was going to be an $11 trillion market, and you caused every company and every human alive with a pulse on the planet to dive into IoT. Where's that bag of cash? And so a lot of people always had the notion of a schema, like a data schema, like that's coming off of this device, perhaps, that's monitoring a machine or a car or whatever. And so I think it started there, and you'd see a lot of kind of basic kind of JSON looking schemas to describe what's coming off a device. And I think it evolved from there, and so, gosh, I got really deep into it when I was recruited into Hitachi. And so I was CTO at Hitachi. And so you can imagine I spent a lot of time flying between Seattle, Bellevue, Santa Clara, and Tokyo, and Hitachi City, and Shinagawa, and places like that, and living in Japanese factories. And I firmly believed when we built our industrial IoT platform, Lumada, that digital twins must be at the heart of the system, because that's where a lot of the value is going to come from. And so we called them asset avatars.
Asset avatars.
Yes.
Okay.
I know, isn't that crazy? That seemed to resonate better with our colleagues in Japan, though. Yeah. It just made more sense to them to call, obviously if you're a manufacturer, you're kind of thinking of everything as an asset anyway. And they just thought avatar resonated better than digital twin, as far as kind of, but it was the same thing. Yeah. And so you would model, the holy grail, everybody's talking about machine learning and deep learning, and everybody and their dog throws around AI. They don't even know what they're saying usually, most of the time. They just say it. Everyone's trying to show how smart they are to their friends, I guess. And and so but and so part of the deal with digital twins, it was kind of hand in hand with things you wanted to do with machine learning. And so there's this notion of a digital twin model or a prototype, but basically, like, if you have an asset class, like I have some kind of machine, or we'll just make it simple, let's just say it's a car. I've got a 2018 Ford F-150 pickup truck of this type. And it's kind of the base. If you're a programmer and you think of base classes and inheritance and things like that, that's another way to look at it. And so that's the model. And then it's got all these properties about it, right? 4 tires, PSI in the tires, the engine, the oil, all those different attributes of that vehicle. So you assigned all those properties when you're building the digital twin of the model itself. And you're doing it, in my view, I was always doing it to try to help the analytics, because a lot of people just think this stuff is magic and analytics are going to give you something, but it's not that easy. And so giving all the help. And so for whatever that property is, if it's right front tire, and what do I care about the right front tire? I care about the air pressure. And so you say, well, the unit of measure that I'm talking about that you care about is PSI. And the data type maybe is an integer or a floating point. And you define all these things, you label them, and you say, and you're doing all this because analytics are going to be applied to that, and KPIs. And if anything you can do, because the idea you're going to interrogate, like, I always think about, there's IoT, flooding in data, plumbing, there's your twin. And so there's the model of that Ford F-150, but then there's the instance. There maybe is 10 million instances of that F-150 out on the road, and they all inherit all the properties from that model to get that, because you don't want to have to keep recreating those properties every time you add a new something into your system, right?
Right.
And so you inherit that. And so what a lot of people get confused around digital twins, whenever I see people say it, they immediately always show me like a 3D model of a offshore drilling rig or something like that, and they go, this is a digital twin. Or someone with their VR glasses, or say, they're seeing, they go, that's a digital twin. And I just say, well, those are just views of a digital twin. A digital twin is really just a data model. It's a data structure.
Well,
it's
the digital twin really says, what's the digital description of all of the elements that make up whatever it is, a car, a offshore drill rig, my dad was worked in the machine tool industry, and they did early manufacturing robots, and
sure,
they used to have they had the physical. This was back in the 70s, and that where they had the one in the factory, and they had the one on the floor. And when the customer had a problem, they reprogrammed that robot to act like the one that US Can was using for beer can manufacturing, to see why it wasn't operating the way it should operate. But it was a delayed effect. It wasn't a digital twin, it was the physical twin. Like, Houston, we have a problem. Go simulate it in the physical module sitting in Houston, type of a thing. But, and again, I think it's showing the progress. Where in the maturity model do you think the digital twin? You were talking about the fact that McKinsey said, "Oh, IoT is going to be this absolutely huge market," and everybody and their uncle, jumped into the market. So, in the case of digital twin, where do you think the maturity model is? Right, every innovation has a maturity model. Are we still kind of in that early stage, or are we kind of?
I'm going to say that we're at the bottom of the first inning of the baseball game. Maybe is where we're at with digital twins, because you hit it on the head, the fidelity, because there is a wide range, because a lot of stuff is just, in fact, let's just assume most of the so-called digital twins out there are low fidelity. And so when they talk a good game about, this is going to always be exactly what the real thing is, well, it's not. It's going to be a partial view of what the real thing is, because we're still in that low fidelity. There's some people that are doing some pretty cool stuff. But it's just early days. People are, like lots of things in technology, we're kind of stumbling through the dark, right?
You-
Trying to figure out. We have an idea of what it should be. I know I have an idea, and so I boldly, stupidly write about this stuff, and I talk about in great detail how all these different things can be done with digital twins. But I'm so paranoid that someone's going to call me out on it. So as a person who's still a developer and an architect, I actually will write the code to make sure what I said actually works.
Well,
if someone calls me on it, I was like, nope, here it is. I made it work. It works on my computer.
Well,
Yeah.
in you and I were talking before, right, about our history, right? You think back on all the innovations we've touched over our career, and some got you call it right, sometimes you call it wrong, right? You think it's going to happen sooner than it is, or that there's going to be more adoption for whatever it is. We were talking about mobile phones, and
Right.
when you were at Microsoft and HP, we had the iPac. We thought this was going to be the thing for take a PDA, slap bubblegum a phone onto the back of it.
That's right. That's really all it was. That's what a smartphone was. It was a PDA, put in a SIM card, put in a radio stack, and ta-da. And it's such a weird thing. I remember as we were the sun setting on Windows Phone, and you had so many analysts saying, "Oh, well, Microsoft was just late to the party. They were too late. The iPhone beat them to it, and the Android." And I'm like, no, those weren't even a twinkle in anyone's eyes when we were building smartphones. Actually, we built those original PDAs, to compete with Palm in the late 90s. The Palm Pilot was super popular, and later Handspring, and then Palm again, right?
Yep.
And so we were competing. We used a real-time embedded operating system to build a PDA, and then we put in a radio stack and built a smartphone. And, it's like, well, of course, this is what we're doing. Now, maybe some of the user interface decisions were kind of not good with the start menu and things like that, for your fingers. But gosh, it is interesting. And so the reality is just kind of like as you mentioned when we talked earlier, Nokia had the communicator in the 99, flip up little device, cellular. That was arguably the first smartphone. Cellular
and then you had
computer.
big winners. You had like BlackBerry, and when you think about it, and I think this is kind of the repeat theme about any innovation, right? First person out of the gate most likely will not be the one that does the largest of the monetization of the value, right?
Yeah.
People forget about the fact that Google was not the first search engine, right? Or
right.
iPhone,
we were using Alta Vista,
right? Alta Vista, Yahoo, Ask Jeeves, if you remember Ask Jeeves, that was actually that was a Compaq product. Compaq actually developed Ask Jeeves, or even Apple. iPhone was not the first smartphone, right? And
they weren't the first music player either,
right?
They were super late to the party.
Yeah, like what was it? Creative. What was the name of it that had the first PDA thing?
One. Toshiba had a lot of people.
Right.
Had
Sony
MP3 players, right?
And so the question always gets into amongst in the innovation game. Those of us that are been innovators for long parts, or even new innovators come in. This is the advice I give them: is like, be careful here. Don't tout the fact that you're first in the market as some big, huge advantage. Right. History says it's a disadvantage, right? And
but remember during the .com era, that's all they talked about was the first mover advantage of Amazon or other people, and how that was going to make all the difference.
Even Amazon wasn't the first online bookseller.
Sure.
Right. So or the first credit card processor. Remember putting credit card transactions onto the internet. This is always, people always ask, like, how, who do I watch for trends, right? Well, talking to we have a common acquaintance, Woody, talking to Raul Sood, who used to run Microsoft Ventures, who actually worked for me at HP. There's people who are kind of the canaries in the coal mine. What's coming, type of a thing, and you keep an eye. But one of the industry segments, it's going to sound weird. I know people on the show here are going to freak out when I say this, but one of the industries you do want to watch for trending, is a morally questionable industry. It's porn. Porn was the first industry to do credit card transactions ever. They were the ones that defined personal private information and worked out all the rules with the credit card companies for credit card transactions. The porn industry was the first one to put in and work out the early digital rights management. All the DRM work on video streaming was all done in the porn. And, and people are like, oh my God, I don't watch porn. I'm watching the industry, because you have to find these industry segments that are new, right? And there's been a lot of interest in digital twins, but like you said, we're in the bottom of the first inning here, right?
Right.
Who do you watch? Who would you watch on digital twins? If someone's saying, hey, this is an area of segment, I'm innovating for a big multinational industrial or auto or consumer packaged goods or whatever.
Yeah.
Who's the trendsetter for digital
Well,
twin?
of course it's me. Everybody knows that. I'm the doctor of digital twins. So, hey, kids out there, make sure to follow your Uncle Rob here on that stuff. But yeah, you know what? The thing is I don't know if I would follow one company.
Right.
I think I would make sure I'd look at a whole basket of companies, because there's a lot of them. They're all over the place. There was I don't know if you know this guy. It was a guy, Richard Solly. He heads the object management group, OMG. And so been doing that for a long time. And I remember him reaching out to me a few years ago saying, hey, I want to get you and like Bill Rue from GE Digital, who did Predix, and some other guys together, and let's put together a working group to maybe create a consortium for digital twins. And so we worked that out, and we created the Digital Twin Consortium. And it's kind of an outgrowth from, there's an industrial internet consortium that's been out there for a while. And so we did that with the whole thinking of everybody's going a million miles an hour, and they're all going in different directions.
Right.
You know how there's no standards. Digital twin is whatever I say it is in some ways,
Well,
and so,
I also have an opinion. This will get me into trouble, I know, but I think the SDO organizations, the standard development, the traditional ones, are not keeping up with the pace of change.
True. You're right.
SDOs take way too long for industries to try to rationalize. It takes get 5, 8 really smart people in a room, and let them just crank it. It's like, HTML5. How did HTML5 come around so quickly? Google picked 5 other companies to come into them in a huddle. They cranked out HTML5. They coded it while they were developing it. And then they came out and go, here it is for free. You can have it.
Right.
You're
right. They got ahead of the W3C.
Yeah.
And made those, they put their feet to the fire, didn't they?
Yeah.
It's like, hey guys,
it's done. It's coded.
You're right. They hadn't done anything since HTML like 4.01 or whatever back in 99.
Exactly.
And it's like, come on, guys.
And that's why I think, so you're talking about this consortium. That's interesting. So
it is. I don't think they've made tons of progress, to be honest with you, from just watching. And so lots of people, you know how it is being in technology, standards, bodies, consortiums, they usually, it's actually people who just go do things, and they create the de facto standard that didn't come from, a whole bunch of PhDs sitting around together for years saying, well, I think it should be this or whatever. Right. I think that's where we are with digital twins. I remember my first glimpse, the idea. So if there's one person to follow, there's a guy, Dr. Michael Greaves. He's the one who really kind of kicked things off, talking about it a lot. And you see him at a lot of events, and he and I were at a digital twin and energy event together in December. And I would absolutely follow him. He knows what he's talking about for sure. when I remember back in the 90s, and I was doing some consulting for Boeing. And I remember when they made the transition to design aircraft from paper and blueprints to they started using CATIA from Dassault Systems to create the digital version of an aircraft. And, that was a big leap for them and lots of other people, right? It's like, no, we have drafting boards and that's how we design buildings and planes. And so going to a fully digital way of designing it, and that's kind of part of the discussion around twins. And I'm sure the Dassault system people are going to be shooting arrows at me for saying we're only in the bottom of the first inning, because I'm sure they're like, what are you talking about? Us guys in France have been doing this for decades. But designing like the digital twin, it's like a life cycle. Design the physical product digitally and test it digitally. And so like kind of when I talk about, like we put a car or an aircraft in a wind tunnel,
right,
to see how it behaves, the aerodynamics, doing the same thing with software. If you have this digital twin of whatever, and it's got all these properties and data types, and maybe you define KPIs for every one of those things. This is what's expected, kind of green, and then here's a little bad yellow and red, right? Just starting with that, and then triggering the stuff, and then you force fake data at that twin to see how it behaves, because that's ultimately what we're trying to do is in the real world. Like if you got a wind farm of windmills out there, generating electricity, when the wind's blowing so much, how much is that tower of the wind thing going to start leaning or whatever? How many inches is it's going to start careening over? And so you design it digitally, you do simulations by forcing maybe extreme different types of fake data at it to see how it behaves if you really know what you're doing. And then there's the digital twin at runtime, kind of in operation. And IoT is from your vehicle, from your ODB2 connector in your vehicle over cellular or something, is sending all this telemetry about its health, going through some IoT system in somebody's cloud or whatever, and then hydrating that digital twin. And so there's the latest state of the twin of your car as you're driving. But then there's also the historical state, like every timestamp. You always hear about time series and time series databases and things like that. Well, it is like a time series thing. And so there could be millions of instances of over time of your digital twin's latest state. That whole long thing, we call that the digital thread. And that is the historical view from the birth of that product through the simulations and testing to at runtime and ultimately till you retire the product. That's why a lot of like if you think of PTC with ThingWorks, they were one of the early players in twins and industrial IoT, actually, way before most of the big players, that I was involved with got into it. And it made sense to them. They're a PLM company, product lifecycle management. And so it was like, well, duh, of course we're going to do this to manage the birth, modeling, testing, life and death of a product, its life cycle. And so all that makes sense. And so this is all good stuff. And so you can query the latest state. You always know the latest state of all your twins, your instances of all your fleet of vehicles or whatever it happens to be. And then you can query and do analytics on the historical state. You can also aggregate all those twins together. So for instance, if you have 10 million of instances of a type of vehicle on the road, and as you're doing analytics across the aggregated view of all of those, because we're always looking for that needle in a haystack, right? You might say, wow, we're noticing a high percentage of these vehicles is maybe the water pump's going out at 60,000 miles or some kind of fault is happening and we're seeing it across there. Maybe we should do a recall on those cars, something like that.
Right.
So anyway, those are some of kind of the ideas around that you can work with.
So
Sky's the limit.
So question for you, we've been talking about auto examples, right? It's probably the one that we all, we think about, but I think also about industries that are in transition, like the auto industry, right? So, I actually own a Ford F-150. I'm on my 35-acre ranch here in Colorado, and I also have two Ford Explorers. Right, we're a Ford house. My uncle used to own Ford and Lincoln Mercury dealership, so we only have Fords in our family. But Nowadays, though, you look at all of the new EVs coming out, whether it be a Tesla or the Mustang E, which, maybe someday I'll grow up and, buy one for myself.
You might have to try one out. Yeah.
You have to try one out. But, and you look, for instance, one of the things that, my team's been looking at is the amount of data that an EV vehicle generates that the manufacturers want, meaning they want to grab that data, all that sensor package data, off that vehicle to send it back so they can do effectively this digital twin across. And they do the digital twin not just on the physical vehicle, but the vehicle tells you about the environment. So 5 of us in this community own the exact same vehicle. Not only can you see, is the vehicle acting the same? Are there issues with the vehicle? But the environment that the vehicle operates in, road conditions, traffic, changing of signs, patterns, all of those types of things.
Yeah, the weather.
One of the big challenges is that's you're pushing up a lot of data every night off that vehicle, and it's a challenge. It's like, the early days of Tesla when you bring your, everybody in California. I lived in Silicon Valley for years. Everybody, and everybody wanted to own or owned a Tesla. Everybody bring it home and plug it in, and the car would immediately start to charge. Well, the power grid couldn't handle it.
Right.
So then Tesla had to go back and say, okay, we're going to stagger starts. We're going to do it in off-peak hours and all, So they had to program into your Tesla vehicle to change the charging mechanism so it wouldn't all hit the grid at the same time. We're seeing the same thing on the data network. Everybody comes home with your car. You plug in the power. It connects to the network. And everybody's trying to jam all this data up in order to feed the digital twins. And it's a dependency that people don't think about.
You're so right. You're so right. And that's also kind of a part of a maturity model when you think about it. Like the digital Tesla's, that's a great example you bring up when you think about vehicles. There's a digital twin for real of every Tesla. A lot of times, like you might say, well, hey, you know how you're trying to make things relatable to people. And I'll say, well, open up your glove compartment and pull out your owner's manual. Kind of think of that as like the digital twin-ish of your car. Well, Tesla has that actual digital twin, and it's alive, and it's sending telemetry about all those properties we're talking about of all the systems of the car. And you're right, it's environment. You need to have that context around its environment because, they say your Tesla is worth more money over time because it's becoming better. Kind of like an IoT device. We're updating it. We're improving the product based on the behavior and how you're using it. Oh, wow. We'll send a firmware update or whatever to this device.
Well, in this case, Tesla actually takes and they create a digital twin of your driving environment with your digital vehicle. And that's how they develop and test things like autonomous driving, right? So they create, they gathered all your sensor data. You're driving around. And you're effectively the equivalent of the old Google guys that used to drive Google Street View vehicles around.
Yes.
Effectively, every Tesla owner is a non-paid employee of Tesla because by the fact that you drive it around, you're feeding and enhancing and adding fidelity to the environmental digital twin, which creates a better platform. So Tesla builds a digital twin of a current vehicles or new vehicles and puts them into that environment to see how do they navigate with traffic? How do they navigate with signage and stop signs? And will navigation work? And create weird conditions that happen in real life because we're all human and we do stupid things and we cut people off and we run lights and all those kinds of things.
Absolutely.
And I think people don't realize it, but today you just look at the vacuum cleaner of data happening out there. It is massive. It's a massive amount of data.
And it parallels the stress, like your example, how all these new Teslas in Silicon Valley stressed the power grid. It wasn't prepared, or people weren't prepared to having what did you have to put in 220, 240 in their house, their garage to power those things.
50 amp.
That was all new. And so you're stressing the power grid, and you're stressing data and servers in a way that they hadn't been stressed before. And it's just getting bigger and bigger, for sure.
Yeah, it's an interesting problem, but I think, and look, and I've had the benefit of spending a fair amount of time with Elon, right? The guy's scary smart. He's also scary on the energy level. Like, I did this series of meetings. He asked for some help on the design of the LCD display that's in the dash, the oversized vertical. And HP was the largest manufacturer of LCD displays in the world for compute and those types of platforms. So how do you build one that passes, the DOT requirements for crash testing? Having a display inside the dash that's that big and meet DOT requirements is kind of a challenge. So we were helping, brainstorm on, things that we learned about breakage and those types of things on those displays. But every time I was in a meeting with him, in a series of meetings, the joke was I'd have to go home and take a nap. Because the guy's energy level's off the scale. He's constantly just churning ideas and pushing, and why can't we do it this way? And no, that's the way it's always been done. We need to do it differently. We gotta find the new way, the better way. And it's pushed a lot of people. You got, GM with Cruise and their new EVs. Yep. You got Ford. What they say? They're like $30 billion they're committing to their electronic vehicle.
Yes.
And you can commit those kinds of things when you change the model. And I think that's where the digital twin comes in, because it changes the whole process of how do you build product in the future? How do you build generations into your products in the future?
No, that's so right. That's so right. Also sticking with cars, like a maturity model, I would often talk, just even when I was just talking simple IoT stuff, I would, that kind of crawl, walk, run thing. It's like, well, with your car in the olden days, you're hearing some rattle or you got some problem with your car and you take it to the shop and they're taking it apart and finding out, gosh, this is going to be a problem. Or, sometimes they say, oh, actually you can go another 30,000 miles and you're going to be fine. And then some other times like, oh, we got to fix it right now. And so there was investigation by a human. Then we went a little further into the future. And you'd say, I think there's a problem with my car. And you'd go to that auto body shop. And what was different? Oh, we're going to plug it into the computer now. Right. And they plug your car into the computer and they would get codes. And that's how they would diagnose problems with your car. And then they would tell you what the deal is. And so now today with cellular data, telemetry coming, it's like, well, we could just stream. We can either, when you get home, you can upload a day's worth of data over your Wi-Fi or whatever. And or if you've got LTE or 5G or something on your car, you could stream it that way. And so we always know the current health and state of your IoT device called a car, and get ahead of problems, early warning, right? Yep. I talked about the aircraft engines as a service kind of thing that GE had done when I was at Hitachi, and we built this Lumada industrial platform, and we had our avatar digital twins and we had our analytics. This opened up a world of new business models that we could go after. And so a great example is back then, so this is 2016, whatever timeframe, a little earlier than that, the UK government put out an RFP. They needed to replace all the intercity trains throughout the whole country. They were really old, it's time to replace them. And so like a lot of companies, whatever, here's an RFP. And so all the usual suspects in Europe, Alstom, Siemens, whatever, show up, and yes, we'd love to build new trains for you. That's going to be a great deal for us. And it's going to cost you this tens of billions of pounds, I guess, right? British pounds. Well, Hitachi, lots of people know about bullet trains in Japan and Asia, but Hitachi didn't have any footprint in Europe. And so we had the confidence, because Lumada, one of the choices I made, as the designer of the product, was we're not going to be totally taking hard dependencies on anybody's cloud. It's going to be portable. It can run in any cloud. It can run on-prem, and it can run on a bullet train if it has to. And so making it portable was a key deal. And so what we did is we had Lumada running on Hitachi bullet trains with about 40,000 sensors on the train, streaming telemetry into it at light speed and munching through that. And then if there's a big problem, maybe you do LTE right then. And then for all the little things, you wait till you get to the train station, kind of like your Tesla at home, and use the Wi-Fi or whatever in the train station to upload. Well, the fact that we had the confidence to say, we'll do trains as a service. And so instead of you having to pay insane CapEx, we're just going to do a SaaS model and you're just going to pay as you go. And we won the deal against all odds. But was it against all odds? Obviously, it was financially much more attractive to the UK government to not have to pay this giant ton of money up front, and then there's SLAs, right? On are you meeting the requirements to keep paying you every month? So it was a cool example, because a lot of people talk a good game around the benefits of IoT and those kind of things, and that really made it real, and it made it real in making a sale, in a big way.
So here's the question. Because you're talking about Netcase, you've put that entire digital twin platform inside. So it's literally the twin inside the real device, right? But it's now shifted from an analytics platform to almost a real-time synchronization problem. I've got the live and the twin, keeping them closely synchronized, because the twin can then say, something's a little off here, type of a thing. And you talked about, okay, if there's a problem, pop a flag, send a signal up to LTE or the 5G or 6G soon enough, to say there's an issue, there's an issue here. How is that the roadmap for digital twins to be an analytics kind of an approach today to getting to, more, wouldn't call it real time, but more synchronized monitoring, and then where does that go?
No, I totally know what you're getting at. You're right, because certainly things like machine learning and all that's all batch based technology, and there's streaming analytics, the data in motion, and you're analyzing as it's flying through. And so we would hydrate the twins and know what's good condition for 40,000 sensors and aspects of this train, and then what's bad. And so it was a streaming model locally, right, since we had servers on the train, right? That normally could have been in a cloud or in a data center or whatever. And so it was doing streaming analytics there locally and looking for those, kind of green, yellow, red as far as urgency. If it was really, really bad, that, because we also had the notion of orchestrating. Here's the, people talk about edge computing a lot these days. And one of the fundamental challenges around edge computing is orchestrating edge nodes. There's the endpoint, and some people are all over the map of what they think edge computing is. Actually, it's a location. I know in the industrial space early on, it was maybe an industrial PC. HP makes edge line, edge compute devices, which are great. And you put them out there, because a lot of people don't realize in factories and stuff, they think it's going to be all this light speed technology. It's like, no, you're going to be using a RS-232 serial port to connect to some other thing. And it's the slowest thing you've ever heard of in your life, because you're dealing with all these protocols, weird industrial things, that have been around for decades. And so edge orchestration, though, is a key thing. Cloud is relatively easy comparatively, because cloud is this hub and spoke, one to many thing, right? Everything streams to one location ish. I know you're doing load balancing and stuff to the cloud. And so it's one source of truth and you can work on it. When you're doing edge and you're basically saying, well, I'm going to have thousands, of edge nodes all over the place in a factory, or in telecom now, they're doing something they call MEC, mobile edge computing, multi-channel edge. There's about 5 different names for it now, but the same acronym, where they're going to put edge computing in base stations, like at the bottom of cell towers, to do compute workloads there. Because a lot of the edge stuff is around lower latency. Right. You're closer to the source of the data. And so there's the really close to the source of the data, like with an HP edge line, or you've obviously, we always talk about Moore's law. The endpoint itself might have enough compute power to do, you're seeing like things like TinyML and stuff like that, where we can do some analytics right there if you've got that kind of compute at the endpoint, or you can do it a little further back on an edge computing device, or you go all the way to the cloud or whatever. You could also do it at the edge of the cellular network, and you hear people talking about edge cloud. It's kind of crazy. It's analysts and architects gone wild, I think, is what it is.
Yeah, well, I think it also talks to just the normal cycle of innovation, right? It's one analogy is it's like squeezing a balloon. You solve a problem in one area and it pops out someplace else, and you gotta go solve that. Then you gotta go solve that, right? Because nobody ever thought about edge compute, because it's like, well, it happens pretty fast as I can tell, right? But all of a sudden, you start looking at, sub-nanosecond transactions, and all of a sudden, Einstein's equations you can't violate. You kind of get stuck into a laws of physics that you just can't beat.
Yes.
So distance is your enemy, whether that's distance of, interstellar stuff, or you're trying to go from Chicago to LA. You can't beat the distance. Distance is your enemy.
It turns out the speed of light is just too darn slow, right. And it's a killer. It's a killer for you trying to make a stock transaction from Kansas City to Wall Street, and it's a killer for cloud computing when you need nanosecond response times. And that's why you heard people talking about fog computing for a while, but edge computing, now some people might go, well, wait a second. We've been doing this forever. Edge is actually the default location. We're already here at the edge. Cloud is the new thing, or cloud's the new old mainframe thing, or whatever you want to call it. It's the new old thing, right? Edge is kind of where we always were. And so we just kind of lost our minds, I think, maybe a little bit. But yeah, guys on factory floors, it wasn't like we need some cool new techie geeked out thing to do. It was pragmatic. I need the answers to my questions in nanoseconds. And so I need that compute workload to be here on the LAN, potentially right next to the machines. And also sometimes it's not only is it latency, because sending data to a distant cloud takes time, as we know. It's also expense. If you're spending if you've got giant machines in a factory that are spitting out terabytes of data every hour, or a car that generates terabytes of data every hour, is it economically feasible to send that data over expensive bandwidth? Maybe not.
Well, there's also another part of the equation, which is reliability. If you take out a dependency of the network and everything is local, that's one less failure point. Also, right. in the grand scheme of things, right?
Good point. You're absolutely right. Do it local if you can.
Yeah, and it's actually the reverse of cloud, right? You have this cloud aggregate up, get to these big hyperscalers, big racks, football field sized data centers, and now you're throwing a bomb in it, and you're doing these little bitty micro servers, and you're putting, in effect, rather than having 5 data centers in the United States, you got 500,000 data centers in the United States, because you're embedding them. And there's actually discussions around, do you actually even do microservers in people's homes? Do you put them into other CPE gear that people are putting into their homes in order to literally have a micro footprint that, cloud edge applications can take advantage of, that are literally in every home? So now you're talking about 300 million micro data centers now across the United States.
Yeah, you're so right. You're so right.
It's crazy.
It's pretty crazy.
So as we wrap this up, one, Rob, thanks for taking the time for joining. If people want to follow what you're doing, what's the best way for them to find you?
So it's at Rob Tiffany on Twitter. I'm all over LinkedIn, probably too much every day. You can go to digitalinsights.ai. Is a good place. I have a lame podcast that hasn't been going on for centuries like yours. But it's like a Digital Insights podcast. The one thing that a lot of people might see me on, though, every week, though, me and some other analysts, and three of us are actually inventors of a lot of the primary IoT technology that people use today. We have a thing called IoT Coffee Talk that we do every week, and that's on YouTube. So definitely check out IoT Coffee Talk. It's like a totally irreverent, kind of like watching Sports Center view of IoT and all the associated technologies.
Great. Rob, again, thanks a lot. Appreciate you taking the time joining us on the show here today.
Thanks for having me. This has been great.
Thanks. So what did you think? What area of digital twins could you apply to whatever innovation, organization, product types that you're working on? Digital twins can literally be applied to anything. If you're the manufacturer of plastic bottles, it could be factory-based. If you're doing vehicle design, if you work for an auto manufacturer, it can be applied. Consumer packaged goods, you're in retail, grocery stores, you could apply digital twins to everything inside that store. Where would you apply digital twins? And as Rob shared, we're in the bottom of the first inning on digital twins. We are in the very early stages. So it's not like you're late. You have an opportunity to think about what is the role of digital twins and what innovations would you create with a digital twin strategy, meaning you get a complete digital model of what it is you're working on, and you could tweak it, test it, innovate on it, improve it. What would you do with a digital twin? I'd love to hear if you've come up with some crazy ideas, or if after you've implemented it, give some feedback. Let us know. You can do that over at theinnovators.community. That's the online community for innovators. It's free of charge. We run it as a platform, as a way for innovators like us, you and I, to be able to get together, share, communicate, and support each other. Look, it's lonely out there being an innovator. You have a target painted on you. Everybody's waiting for that next great idea. So find like-minded individuals, join over at theinnovators.community. Again, thank you for your time this week. Greatly appreciate it. We are really excited about being into season 18 and things that we've got in the pipeline, guests we've got coming on. Hopefully you find these conversations interesting. We would love to hear. So drop us a note. You can send it to at feedback@killerinnovations.com, or you can drop me a note directly, phil@killerinnovations.com. So let me know that. Again, got the favor to ask. We do this show. We've been doing it now 17 years, starting the 18th year of the show, as a way of paying it forward. Early in my career, I'm the beneficiary of just absolutely mind-blowing, positive coaching and mentoring from Bob Davis that put my career on a completely different track. When I asked Bob how to pay it back, he laughs. He goes, "You can't pay it back. Pay it forward." We created this show in 2005 as our way of paying it forward. And we, again, I would love to pay it forward to more people. That's where I need your help. Help spread the word. Let others know about the show. Encourage them to subscribe so they get each week's episode. And that would be the best way to pay back the work that we do in putting out each show that you enjoy, is by helping us expand the listeners who get to know and hear the show. So again, thank you very much. Great. Appreciate the time out of your busy schedule to join us here this week. Love to hear your thoughts on guests, topics that you're interested in, so we can look into potentially having them or those topics covered on an upcoming episode. So with that, have a great week. Work on that idea. Don't let the innovation antibodies get you down. Go change the world. We'll talk to you next week. Bye-bye.
Podcasting nonstop since 2005, this has been the Killer Innovation Show on the Innovators Network.
This show is distributed by the Innovators Network. For more information and other great shows and content, visit theinnovators.network.